to lesson 2.6, molecules and ions. Before you talk about molecules and ions and the compounds they represent, we must talk about bonds. Any type of bond is simply a force that holds atoms together. Covalent bonds are formed by sharing electrons, so if elements within the compound actually share the electrons, then that results in something called a molecule. And molecules can be represented by chemical formulas. So you can actually just write out the chemical formula. Structural formulas can be drawn out. Space-filling models or ball and stick models can represent molecules as well. With a chemical formula actually can be used to show the ratio in ionic compounds as well. But chemical formulas use symbols of elements to indicate the type of atoms present in a molecule, and they use subscripts to indicate the relative number of molecules. So for example, relative number of atoms. So for example, H2O is water, which tells you that water is composed of hydrogen and oxygen, and the ratio is 2 hydrogens to every 1 oxygen. Example given on this slide is carbon dioxide. So carbon and oxygen in that compound with a ratio of 1 carbon to 2 oxygen atoms. Structural formulas, they show what the individual bonds are in an atom. They can also help, you can use a structural formula to show the shape, but you have to show the 3D structure of that, and you'll see that on the next slide. Space-filling models will show you the relative space that each different type of atom occupies, and then the ball and stick model is a representation very much like the structural formula, only it's more three-dimensional. So here's methane, CH4, represented in structural formula. Notice this one has dashed lines and a heavy line, so that indicates that this hydrogen atom and that carbon atom are in the plane. So very much like this would be in the plane. These two hydrogens go back away, that's why they're dashed, and this one is heavy, so this is the one that's coming out towards you. Space-filling model shows you that the carbon atom is much bigger than the hydrogen atoms, and how it's the hydrogens are evenly distributed in order to negate the electron repulsions. And then the ball and stick model helps you see shape as well. Ions, on the other hand, a chemical compound can also be held together by an ionic bond, and ionic bonding is done because there's a force of attraction between oppositely charged ions. There is a specific name for a positive ion. It's called a cation. Positive ions are formed by losing electrons. Metals on the periodic table will form cations because they will lose electrons to become more stable. Nonmetals will become anions because they will gain electrons to become more stable. So for example, sodium chloride. Sodium in and of itself is a metal. Most people think of salt when they think of sodium. Sodium is actually a metal. It's a very soft silver metal. Sodium will lose an electron to become a +1 ion. Chlorine is a nonmetal. It's very happy to take the electron that sodium gave up and form the chloride ion. And so then you have sodium chloride held together by an ionic attraction. Ionic solids can be composed of simple ions, like the example we just talked about. Sodium chloride has a sodium ion plus a chloride ion. But ionic compounds can also be composed of polyatomic ions, and polyatomic ions, within themselves, they behave very much like a molecule where they're bound together with covalent bonds, but as a whole, they're either deficient of electrons or have additional electrons. And so an example of a polyatomic ion compound is ammonium nitrate. Ammonium behaves as a whole unit, but it has lost an electron, and so it exhibits a positive charge. Nitrate also behaves as a whole unit, but it has an additional electron, and so those electrostatic forces hold that ammonium nitrate together. So let's go back to what I said, because we haven't really talked about the periodic table yet, and let's go back to what I said about metals and nonmetals. And so if you look at the periodic table, if you happen to have one in front of you that you can look at, there's also probably one in the front cover or the back cover of your chemistry book. You will note that on the periodic table, the metals are on the left-hand side. The nonmetals are in the upper right-hand corner. So everything to the left of what we call the stair-step line, which we'll talk about more, are metals, and everything to the right are nonmetals, and then we kind of have our in-betweens, our metalloids. And so what we're going to do is we're going to predict whether these atoms will gain or lose electrons when forming ions, and then we're going to try to figure out which ion is most likely. Like I said, we're kind of jumping ahead. You'll understand this more when we look at the periodic table. So radium is actually element number 88. And so it says to the left of the stair-step line. So radium is going to lose electrons because it's a metal. Now, how many electrons is it going to lose? Well, it's going to want to become like the nearest noble gas. And so the nearest noble gas in numbers to radium is radon, which is element 86. So radium is going to want to behave like radon, but in order to do that, it needs to lose 2 electrons. So it needs to get 86 electrons, just like radon does. And so radium is going to lose 2 electrons, and it's going to become a +2. So let's look at indium. Indium is element 49, and if you look at that, it's in that group that's kind of below the stair-step line. Indium is a little bit different because indium is what we call a main group element. And so we need to ignore everything in the transition element range. Okay, so first off, indium, because it's to the left of the stair-step line, is a metal, so it's going to lose some electrons. So we know it's going to form positive charge. But what we have to do is we have to ignore the transition metals in between indium and strontium. And so in order to slip back and be like the nearest noble gas, which is technically krypton, indium is going to lose 3 electrons. Now that one's kind of difficult, and you'll see when we do the periodic table, we'll see how we can do this very easily without having to figure out whether it jumps to or slips back to the nearest noble gas. Let's go ahead and look at phosphorus, which is P. Phosphorus is element 15. We're going to ignore that whole transition thing I just talked about and just look at it. Is phosphorus closer to 10 in number or 18 in number? Well, 15 is closer to 18. And so phosphorus is a non-metal because it's to the right of the stair-step line. So it's going to gain electrons. How many electrons does 15 have to gain to get 18 electrons? There would be 3. And so phosphorus is going to end up being a -3 charge. Same kind of idea for tellurium. Tellurium's down there, element 52. Very close to xenon, which is 54. Now notice tellurium is not going to become like xenon in terms of protons, because tellurium couldn't be tellurium with 54 protons. So it has to maintain its 52 protons, but it would gain 2 electrons to become electrically like xenon. And so that one is going to be a tellurium 2- ion, or a telluride ion. So we went through and we talked about ions and how they're formed. And what did we do here this whole time? I mean, I know I talked about having its identity being like such and such, but what was I really changing? I was changing the number of electrons. So an ion is formed by adding or subtracting electrons. This is a jump ahead kind of problem as well, but let's go ahead and let's try to do this one. In this particular compound, we have it's XCl2, and we're trying to figure out what the identity of X is. And so what I want to do first is I want to use this part of the compound to determine what the charge is on this half of the compound. So when you write an ionic compound, you always write the positive ion first, so the metal, and then you write the nonmetal. Now, if we look at chlorine, chlorine is element 17. When chlorine becomes an ion, it looks very electrically like argon, so it needs to gain one electron. So chlorine will be a -1 charge when it's in an ionic compound. there are two -1 charges. So in order to balance this out electrically, if this half of the compound is -2, this must be +2. Now we can go on down here. If the ion has 36 electrons, so it's a +2, has 36 electrons, that means it needs to have 2 more protons than electrons to be a +2. So if it has 36 electrons, adding 2 gives me 38 protons. We look on the periodic table. The element that has 38 protons, the only element with just 38 protons, is strontium. So this particular compound is strontium chloride. So the correct response for this is C. So that concludes the lesson on molecules and ions. We're going to move next to the periodic table, and hopefully that will clarify a lot of what we've talked about today.